Blender 5 has arrived, and it brought a lot of new features and capabilities. In particular, something that is very interesting for scientific research and for scientific visualizations are the new geometry nodes for grid and volume creation. Now we can generate some grids from mesh, and we can define some properties on this grid. Additionally, there is a lot of new operators like divergence, curve, gradient that we can apply on these grids, and we can define some fields in these grids. In this video we will start exploring these nodes. We will create a scalar field, we will compute its gradient, and we will create a set of glyphs to visualize these vector and scalar fields. We will animate some quantities, and most important, we will introduce the new set of possibilities that Blender has provided to create stunning scientific visualizations. So let's start with the tutorial. Okay, so let's start with our tutorial in Blender 5, the beta version, which means that this is not an official release, this is just a pre-released version, which may have some bugs. Let's start with the building a scalar field, and we will visualize it in a nice way with Blender. So let's start with our standard cube. We will just scale it twice, and we will displace it 2 meters. So it is located in the floor, in the ground. What we want to do is Control A and apply all transformations. This will be helpful to build our scalar field, so we will not have some underdeterminations or some divergences at the zero of the coordinate system. Now that we have this will be our domain for the scalar field. We will go to geometry nodes, and we will just create our geometry node. We will call it scalar field. Here then we will start using the new nodes that Blender has introduced in Blender 5. One very useful is called mesh to density grid, which in some words, in other words, will take our mesh and it will allocate some density distribution inside with some voxel size that we will provide. So let's give it some 0.01, and we will compute the gradient on the whole cube. So we're placing here value 2. Next to that, then we will build, or we will define the equations that will be determining the scalar field. In this case, we will be using 2 Gaussians, added Gaussians as a density field. What we will be doing here is just adding field to grid, and this will be our topology, and what we will need to add here is which will be the density of this field, of this scalar field. Again, these are all new functions, or new geometries, geometry nodes that Blender 5 has. What we will do then, here we will define the density. For that, then let's add a position node, and we will define an input vector, which will be this will be the position, or the vector position inside the scalar field, and this will be the center of our Gaussian distribution. So we will just make the distance between these two Let's just remind the equation of a Gaussian. It is the radius to the square divided by the sigma to the square exponent of that, minus exponent of that. Here we will compute the radius, which is the distance between the center of our Gaussian and any point inside the domain. Then we will compute this radius squared divided by sigma squared multiplied by -1, and then the exponent of this will be the Gaussian density. So we will then now compute power. We will place here 2, and we will add another value, which will be the sigma. We will place 0.5, and also power. Here then we will divide these two. Multiply by -1. And exponent to this quantity we have just computed. And here we have our density of the Gaussian in a Gaussian form. We will just add it to this field to grid, and if you want to visualize it, this will be very easy. We just add the viewer, and we see here already some density. It is centered in 0.0, the origin of our coordinate system. So we will move it a bit up, and here we have our first Gaussian. Since we want to use this more than once, we will just organize it into a group node with these inputs. So we will just keep it like this, and Ctrl G. This will create this group node with our inputs. Let's go back. Now we have this organized. This is our Gaussian, and this will be the input. Here we can just rename this, call it Gaussian. And here we will just keep it, and we will duplicate this, and just this one we can still copy, bring here same position, but then we will duplicate the inputs, and we will place it as input vector and input sigma. Maybe we can just change a bit the position. Now we will just put this here 0.5, 0.5, and this -0.5, 0.5, so they will be allocated in a diagonal of the cube. This will look like this, but we have to add this value to the other one. And here we have our two Gaussians. Very easily we have created our scalar field. Now what we want to do is create a volume so that we can visualize it. And as a second part, we will compute the gradient and visualize it with some glyphs, some arrows inside the domain as a vector field. This will be what we will do today. So let's visualize this as a domain that we can render. Right now we are only able to visualize it through the viewer. Let's change to cycles, GPU compute. We will create a volume as volume cube. This will be in some way trivial, but it will be the way in which we will visualize what we are doing. When the power of this approach that we are following with the geometry nodes for the vector and scalar fields will be more evident when we compute the advection on this field, and we will compute the vector field. But for now we just want to visualize our scalar field. So we have the cube. We will just do it same size as ours, which will be something like this. If we now deactivate the viewer and plug this here, we will see just a cube, same as the cube that we originally have. Only thing we have to do is set a material. We will now define what this material will be, and we will add just here the density is the density we compute. This is very trivial, as I said, but this will be becoming nicer with the time. So let's go to the layout, and we can just here create our share editor. We will add, instead of this, we will just add a principal volume. In the volume socket. This we can remove. And here we will just add some color ramp, as always. With some nice colors we will define. Let's just add something here in between. Something like this. Yeah, so we will see something like it is getting hotter when the density is higher, or something like that. We don't see the color because we haven't tell Blender to which property this color will be related. So what we do is here on the factor we just add volume info, and we will add it to the density. Now we go to the geometry node. We have called this material, we call it volume, or we can call it better scalar field. And here in the geometry node we will add it this scalar field. And that's all. So now we go to the render view and we see some nice Gaussians. What we want to do, maybe to make it more visible, is just add the emission strength. So they emit from the more strong, they will emit light when the intensity is higher, and then we will just change the color. So we will have these two spheres with some color as we define it. We can also move these on our convenience, but let's keep it for now 0.5. Now that we have our scalar field visualized, we want to create a set of grids that will define the points in which we will add the glyphs or the arrows to visualize the gradient of this scalar field, which will be a vector field, of course. For that, we will then add just a grid. Now we will just add mesh to points. And if we directly add this one here, we will not see anything. We will see just these points in the bottom, so we need to transform it to be able to use it in the position that we want to visualize. So for that, we will add just join geometry here. We will add it so we can visualize everything. At the same time, we will, here in between, we will just add a transform geometry. We will add it, then we will just scale this to the same size of our domain, like this, and we will add some more vertices so that we have a big sampling, or big enough to visualize our arrows. Now we will just translate this upwards to the half, because this is more or less when the things are interesting where the Gaussians are located. Let's do only this one, and what we need to do is to add some arrows at each point. So we will just add instances on points. And it's fine like that. Just let's move this a bit. And what we need to do is here give the rotation and the scale of the velocity or the gradient of this scalar field. For that, let's then compute the, I'll just remove this part. We will not need it for now. Let's compute the gradient, and this will be very easy with the new Blender 5. We just need to create a node called gradient. Now all we have to do is sample this grid into the position of the our domain. So what we do is just sample grid, which will give us a vector on each position or on each coordinate of our domain. Here we will just add position input, and here the value will be a set of vectors sampled here inside. So what we wanted, our scalar or our vector field. We want to add some instances here, give some rotation to these instances and some scale. Right now, let's just try with some sample instance, for example, a cone. If we see this, we will have many cones in the places in which our points were. Just scale this scale down this 0.2, for example, and the height or the depth we will keep it as 0.0 as well. Just add some more height. We will keep it like this. Let's now map this into the our vector field. We will just normalize it. And set Euler. To rotation. Which will capture these values from the vector that we have, the Euler angles, and we give us the rotation we will need to place here. And if we see now we have some rotation of these cones around our scalar field. We are getting now closer to our aim. Let's bring this here and we will maybe make some better arrows. And the next thing we will need to do is scale this to the proper magnitude of the vector field on each point. For that, then we will get this node. We will compute the length. We will now use this value. We will combine x, y, z. We will give here, we will keep the x and y scale, and we will scale the length of these glyphs based on the length of the scalar of the vector field. We will put this on the scale. And we will see now here around our Gaussians we have some bigger cones. Also, please note that here we have very almost invisible cones. Let's add some node here called map range, and this will allow us to control how much we want that the scaling is or the effect of the scaling on the glyphs. Here we have from 0 to 1 to 0 to 1, but if I added here a 2, it will be even bigger. You will see how much I can control this. Now that we have these cones, let's define some better geometry here. So let's start with a curved line. And a circle. Now we will add curve to mesh. And the profile will be our circle. So we will create a kind of cylinder from there. Now we want that this is from 0 to 1. This is the radius. We will add a bit of tiny radius. 0.01. We will add joint geometry. And here we will place the mesh. We will need to modify our cone so that we can place it on the tip of the cylinder, not at the beginning. So we'll just need to add a transformed mesh. transform geometry, and we will add it here 1. And now we have it. We have our very big arrows. It looks quite nice though. Just go back to our map range and let's add 0.1. Here we have some problems, and it's that the cone is too small with respect compared to the rest of the arrow. We will fix that just by adding some bigger depth here. And now we have some nice arrows. We will put here fill caps, which will close the end of the arrow here and in the top. Now just let's add some colors to the arrows based on their length. For that we will do, as always, we will just instances on points. We will realize instances and set a material. Then we will define this material based on some property that we will store. For that, then we will here just add store name attribute. We will call it vector magnitude, and the value we will compute it. We have already computed. We will just take it from our scale, which is here. I will take it before mapping the range because I will assume that this is already between 0 and 1. Or even better to take it from the normalized vector. So I will take it from here. I will compute length, and this will be my attribute called vector magnitude. Now let's go and define this material. New material, here I can duplicate this, but I will call it vector field. And instead of this, we'll just add principled BSDF to the surface. I can remove the volume, and I will add this color here. Instead of this, I will just add an input attribute, and here I will add vector magnitude. Let's go and check here. We have point, vector magnitude, everything's fine. So now we can plug this here, and this will be everything. Maybe better we will set a different color so that it's not having the same color that our scalar field. I will just add some red here. And something very useful for these color maps, scientific color maps, is using here the HSV and FAR, and we will have the ParaView style of these rainbow colors. We can modify them later, but for this example maybe we can start with this. And now we need to do is adding the vector here. I see everything is green, which means that everything is more or less in the center of our color map. If we see here, everything is around here, 0.5. Probably we didn't choose the right magnitude. For our okay, yeah, we haven't added here the vector attribute, the input attribute. So I think this was what is missing. And now everything is red, which means that our values are bigger here than 1. So yes, we haven't chosen the proper attribute here. It's fine, let's choose from somewhere else. Let's take it directly from here. I think it's getting better, but we saw some color variation. If we just connect this thing here, this length, to the value, we will see some color variation on each instance. And this is because we have stored the attribute after creating the instances on points. So this is our problem here. We will just place this here, and this node we will need to add actually here before, so each point will have its own data. And that's it. Cool. Now we have some values, some arrows in this scalar field. We are representing our vector field with some glyphs. I will increase a bit the size of the arrows, maybe something like this. Add some more arrows. This is getting much nicer. I think there is a problem with the Euler-2 rotation we did here. This is actually not the proper node that we should use. Instead, we need to use a node called align rotation to vector. In the C direction, and the vector will be our vector. Now it's more clear. It is much more clear. We have our arrows going inside the density as expected, because this is our gradient the gradient to this vector field. If we displace this grid a bit to the top, we will see still that everything is going towards our density Gaussians. Now let us just add some more grids, some more points, and we will prepare the scene. For that, just duplicate this, create a joint geometry, and rotate this 90 degrees on the X direction. I don't like too much the fact that we see the arrows that has a 0 length. Then what we can do to solve that is just on the scale here, we will also scale it on X and Y. Now let's see how the result is. This is getting much nicer. Maybe we'll just multiply by 2 the values in X and Y. I have edited a bit the scene. I have created some map range for the emission strength, and the last thing we will do is animating these two Gaussians to give some dynamism to the scene. We will just create one keyframe here on this vector by pressing I. And then add some keyframes For example, here we will just move this one to minus 0.5. This one we will keep it. This one we will go to 0. This one we will go to 0.5. Minus 0.5 still. No changes. We will press I. Then we will go 140. And we will create also here 0.5. And here minus 0.5. We want to increase a bit also the C direction. We will add here just 1.8. And by the end we will change it to 2.2 and 1.8. Some random things. Let's see how they look. And that's it for the first part of this video. Blender gives us the possibility to create a scalar field, compute easily the gradient, and then add some glyphs to this new vector field with some instances, like in this case, the arrows. This is very useful for scientific visualization. Blender is allowing us to show scientific results easily in a very impactful way. In the second part of this video, I will show you how to use this vector field to add vector quantities and use of the simulation nodes in Blender to create very stunning animations. Additionally, in the next video, we will be creating a color bar and some scales and ticks. Subscribe to the channel if you want to see the part 2 and the following videos in which we will continue exploring the new features of Blender 5.0 beta. Thank you for watching and see you next time.